Hey guys, welcome back to my channel. It is Chemistry with Samanatif, and right now, what is the topic? Yes, it is organic chemistry. Boom, boom. Organic chemistry, a big name which has tortured many of you, isn't it? Don't get upset on it. It will make the things easier. I will try to make the things interesting and understandable, inshallah. Right now, we are going to unlock the mystery of organic chemistry. Guys, here I have written two subject code already, 5070 and 0620. There are many other subject codes which are dealing with the same content of organic chemistry. I'm not mentioning them right now, but there are many others which are taught in some other countries, and from country to country the subject codes are variable, or from an Excel to Cambridge the subject code are variable, but the content is much similar for organic chemistry. Okay, now moving to the content, if we are saying that in case of organic compounds, what is organic compounds? The subject is specifically, the branch of chemistry is specifically dealing with those substances which have carbon as a part of their structure. Okay, so all those substances which have carbon as a part of their structure are considered as organic compounds, except there are certain exceptions which have carbon as a part of their structure, but we are not considering them organic compounds. What are those compounds which have carbon? What are those substances which have carbon as a part of their structure and we are not considering them as organic? So there are certain, number one is graphite, number two is diamond, number three is carbon monoxide, next is carbon dioxide, next is metal carbonates. Example of metal carbonates are there. And then it is ammonium carbonate. Ammonium carbonate is a combination of ammonia with carbonate thing, so that is called as ammonium carbonate. Then there is another called as carbonic acid. Carbonic acid is a combination of carbon dioxide and water. Here I have mentioned that when there is a rain, you know this thing, that in case of rain, carbon dioxide is being dissolved in rainwater, and as a result it is making carbonic acid. So there are certain examples which have carbon as a part of their structure, but even then they are not considered as organic compounds. Okay, so Sama teacher, you are telling that there are so many compounds which have carbon as a part of their structure, but you are not considering them as organic. Then where are the organic compounds? Yes, yes, yes. We are now moving towards that big list, of the compounds which have carbon as a part of their structure, but they are not but they are not considered organic. That has been discussed, and now that big list which has carbon and they are organic. Okay, now for example, one of the compound which is organic is already familiar to you people, are already familiar with that compound, and that is called a methane. Yes, okay, where we have studied methane. You people have studied methane already in two cases. Where were those two cases? Number one, when you people were studying covalently bonded structure, I have told you in my videos as well that carbon and hydrogen both are nonmetals combining with each other, making covalent bonding due to weaker intermolecular force of attractions. One molecule and the other molecule of methane are not holding each other tightly. As a result of that, methane has a low boiling point, hence it is existing as a gas at room temperature. This was the one scenario of methane which you people have studied already. Now I am on the second scenario of methane, and that is related to air and atmosphere chapter. Those students who are going to appear for their exams shortly, they know this thing that air and atmosphere is containing methane. And where it is containing methane? In the global warming and greenhouse gases concept, methane is there. Methane is one of the gas which is produced by decay of vegetable matter, which is produced by decay of organic matter, which is produced by decay of plant matter, etc., etc., and from the cow dung as well. So these are the sources from which methane gas is produced. Examiner can ask about the sources of methane gas as well. Now these sources are releasing methane gas continuously. Methane gas is a flaming gas. It can catch fire. That's why it is used in our homes for heating and cooking purposes. And remember this thing that sulfur is added to methane gas. Why it is so? Because methane is a gas which is not only colorless, rather it is odorless as well. So God forbid if there is any leakage or stuff like that, it is undetectable. That's why sulfur, which is causing a specific aroma, you may say, or specific distinct type of a smell to that gas. That's why it is added, so that it may be detected. Okay, now if we are talking about methane gas, it is present in the earth environment. I have discussed the sources of the methane gas as well. So now methane gas will trap the infrared radiations coming out of earth, and as a result of that, what is happening, this methane gas is absorbing the heat energy coming out of the earth, and hence as a result, it is trapping, it is controlling, it is keeping a check. It is, you may say, more and more heat energy will be trapped here, and as a result, the overall temperature of earth will be increased. That's why it is called as global warming. That's why it is causing global warming, and it is considered as a greenhouse gas. Okay, this was the detail about methane, which people already know about it. Okay, now many of methane's sisters, methane's relatives, cousins are part of organic chemistry. So we are going to discuss about all those family members, but not at this stage. Before moving ahead, before moving towards the details of organic chemistry, I would like to bring your attention to certain definitions related to organic chemistry. Don't forget this thing, that those students who have already practicing the past papers, they might have seen this thing that examiner is asking, define this, define that. It means that examiner has an attention on organic chemistry, has an attention on different types of the definitions of certain parts of the syllabus. So right now, what is the next definition? And that is called a hydrocarbon. Hydrocarbon is a specific type of a word which many of you might have seen in the different parts of your cities. Might be many of you have seen it is written on different boards and different research centers, different industries, etc., etc. Okay, so those who have seen the oil refineries, they might have seen it there. So it depends upon experience to experience. Now the point is this, that hydrocarbon is a specific class of organic compound which are made up of hydrogen and carbon only. Yes, only. So for example, methane can be categorized as one of the hydrocarbon which is made up of carbon and hydrogen only. So methane is an organic compound which is a hydrocarbon as well. Okay, so there will be many organic compounds which will have a halogen in them, which will might have an oxygen in them, which will might have nitrogen in them, etc., etc., but they are not considered as pure hydrocarbons. Pure hydrocarbons are those compounds which are made up of carbon and hydrogen only. Is that okay? Now I am moving to the next definition. After hydrocarbon, there is a specific type of a definition, and that is called as general formula. Okay, GF, general formula. Yes, okay. Now, when we are talking about general formula, what is general formula? Remember this thing. Before telling you the details of general formula, let me inform you that when we are talking about hydrocarbons, or when we are talking about organic compounds, there are thousands and thousands of organic compounds. Thousands and thousands. Yes, they are uncountable. Uncountable? Yes, let me inform you where are the organic compounds. Okay, let's have a discussion. Consider your hair. You are straightening your hair. Oh my god, so what is happening? There are certain types of hydrocarbons in your hair made up of carbon chains. What are carbon chains? Carbon are attaching with each other continuously, making a carbon chain type of thingy. So when you are straightening your hair, what is happening? That carbon chain is becoming straight up. So this is the phenomena behind the straightening. Okay, so it means that carbon is present in your hair. So you may say this thing a specific hydrocarbon is existing in your hair. The whole body, your whole body is made up of different hydrocarbons. Skin has different hydrocarbons, hairs have different hydrocarbons. When we are talking about sweat glands, they have different hydrocarbons. When we are talking about different amino acids making the building of your body, they have different types of the hydrocarbon. When we are talking about the car in which you are sitting, you can say this thing, that material of those seats of the car have different type of a hydrocarbon. The whole leather which is used in the car has a different type of a hydrocarbon. hydrocarbon when we are talking about the paints, the nail colors, the cosmetics, the food industry, all types of the cosmetics, all types of the pharmaceutical industry, different types of the rubbers, different types of the rubbers depending upon the strength. There are different types of the rubbers as well, different types of the plastics, different types of the polymers, etc., etc. Now move from your side to the different type of plants. Yes, the whole plants are made up of different type of hydrocarbons. So it means that hydrocarbons are thousands and thousands. Now just consider your school and just imagine this thing, that in a big playground you are just imagining this thing, that the whole school is sitting there from playgroup till the largest level. They all are sitting there and all the teachers are holding the separate mics, and they all are giving their own lectures. Okay, every subject teacher, every teacher of 8th grade, the 9th grade, 11th grade, 6th grade, 1 grade, every teacher is now teaching them together. Just imagine, will it be possible for any of the student to understand a single thing? No, 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 this is not possible. So it means that when we are trying to understand the whole organic chemistry without making different classes, it is impossible for us to study any of them. That's why organic compounds are divided into specific classes, into specific families, into specific groups. The families, the groups, the classes of organic chemistry are called homologous series, are called homologous series. I'm writing here homologous series. Okay, now let me inform you very clearly. A homologous series have a specific type of organic compounds in it, whether they are 1000 or 2000, any number. And remember this thing, that there are many organic compounds which we have never known, which we have never discovered, which we are still trying to find. You know this thing, that science is continuously a process, a journey which is not going to its completion. We are continuously determining different types of the elements in the periodic table. Many of you who have a good look, who have a good observation of the periodic table, they might have seen that there is a new element written below S13 just a few time before. Otherwise, if we are talking about group number 17 or group number 7, it was fluorine, chlorine, bromine, iodine, and astatine. But now tungsten is a new element which has been placed over there. So it is just an evidence to tell you that science is a continuous journey. So it is telling us that we cannot say this thing, that this is a specific number of hydrocarbons or specific number of organic compounds which have been kept in this homologous series. They are countless, and they will be continuously spreading as well. Okay, now let me inform you that a homologous series have a specific type of compounds. One homologous series have specific type of compound, the second has its own specific compound, third has its own specific compound. Each of the homologous series have their different names and different types of the properties associated with them. Let's discover what is a homologous series and what are the properties associated, characteristics associated with these homologous series. Let me go there. I will come back to a general formula. Don't worry, I will come back. Okay. Examiner is asking, write down 3 characteristics of a homologous series. Now, at this stage, you all should know this thing, that homologous series is a specific group of compounds, specific classes of compounds, specific family of a compound which has been segregated due to their some common properties. Okay. So instead of teaching the whole school together, depending upon the age, we have categorized them. Age 14 this class, age 19 this class, age 10 this class, age 4 this class, etc., etc. Now we can teach them according to their ages. Okay, and all of them will be able to understand simultaneously, because all of them are of the same age. Okay, or same age group, you may say. So in the same way, when we are talking about homologous series, one homologous series, all the member, whether they are 10, whether they are 100, whether they are 1000 or 10,000, all of them can be studied together. Why? Because some of the properties, I'm not saying all, some of the properties are matching with each other, not 100% same, but matching with each other. Okay, now what are those? Okay, so homologous series have different types of the characteristics. Homologous series have different types of the characteristics. Number one, All the members of one homologous series. I'm writing it very clearly and I'm telling it to you that this is one of the examiner's favorite question. All the members of a homologous series have same general formula. Yes, same general formula. Okay. Number two, all have all members, no? All members of a homologous series have, I'm just directly here, all have same functional group as well. What is functional group? What is general formula? That is I'm going to tell it to you shortly, inshallah. All have same functional group, and then the next is same functional group, hence similar chemical reactions. It means that chemical reaction and functional group must have some connectivity between the two. Yes, hence similar chemical properties. Chemical reactions, you may say. Chemical properties are chemical reactions only. Now I'm on the number three. Members of a homologous series are CH2 group difference from each other, or from one member to the next member, from one member to the next. So these are the three properties of a homologous series which a student should know. Okay, same general formula, same functional group. Same functional group means same chemical properties. Sometimes I have observed this thing that sometimes students are writing same general formula and then they are writing same functional group, and then the third is same chemical properties, which is wrong. Sometimes examiner can consider it wrong as well if he's not that generous. Okay, or if he is generous, then that's another thing. But I would like to inform you that chemical properties are based upon the functional group, so please don't make them two different points. It is good to write them under the similar heading, similar thing, and then you can write that one member you are adding one CH2 into it, and then you will reach to the next member. If you will add the CH2 into it, you will reach to the other member. What is the meaning of reaching to the other member? That is a great detail. We are going to discuss that right now. I am on the previous page again. Okay, now what is the general formula? It is a formula. It is a formula from which formulas of all the members of a homologous series can be found. Okay, so from general formula, for example, if we have a homologous series A, it will have one general formula. From that general formula, if we are talking that homologous series A has 100 members, we can determine the formula for all the 100 members from that general formula. So general formula is a specific type of a formula by which we can determine the formula of all the members of a specific family. Okay, so every homologous series will have its own general formula. If there are 100 homologous series, there will be 100 separate general formulas. Okay, in our syllabus, how many homologous series are there? I know many of you are taking this tension. Don't worry, there is not that huge content, but there is. Okay, now I'm on the next page and I am going to tell you what is functional group. What is a functional group? I will make the list type of things so that things can become easier for you and all of you can sum up the things under one window, under one roof. Okay, now we can say what is functional group. It can be an atom or group of atom or a bond. which is responsible for all the chemical reactions of a homologous series, is called a functional group. I'm writing here. It is an atom, group of atom, or a bond which is responsible for all the chemical reactions of a homologous series. So every homologous series will have a separate specific functional group as well. Okay, it will not happen that they are sharing the functional group with each other. No, every homologous series will have a specific type of functional group as well. Is that okay right now? So this is all about the functional group and the general formula. Right now I am taking you to different homologous series of your syllabus. Okay, now what are those? Number one is alkane. Oh, they have weird name. I can agree. Okay. Number two is alkene. Okay. What? They are associated somehow? You may say. Okay. And then is alcohol. Oh, yes. And then is carboxylic acid. Yes. And then is esters. Okay. Guys, there will be few more which I will teach you here in this chapter to have some additional type of notes, to have some ahead type of information. Okay, and what are those? That are alkynes and that are cycloalkanes. Okay. Now, let me inform you that what are the functional group and general formulas of these. Okay. If I'm writing here, I'm writing general formula. GF stands for general formula, and here I'm writing functional group. It was FG, but I'm writing the whole thing. Okay. Alkane general formula CnH2n plus 2. What is this? It means that number of times carbon present double plus 2 will be the hydrogen. How I'm going to implement that? Don't worry, I will give you certain examples how to implement that, and this way you people will learn this thing, that how to implement the general formula, to know the formula, to know the exact formula of the member. Okay. And what is the functional group? It is carbon single covalent bond, which is the functional group, which is the functional group for alkanes family. So all the members of alkanes family, whether they are 100 or 200 or 1000 or 10,000 or 100,000, they all will have the general formula of CnH2n plus 2. We can find out the formula of all of them by implementing this general formula CnH2n plus 2, and we can find out the functional group, that is C single bond C, that all of the members of alkanes family have carbon single covalent bond as a part of their structure. They all have carbon single covalent bond as a part of their structure, which is responsible for all the chemical reactions of alkanes family, except. What is the exception? There is an exception in alkanes family. Let me tell it to you. What is that? CH4 is the first member of the alkanes family. How it is the first member of the alkanes family? What is the connection of the name with the first, second, or third member? That I'm going to share with you shortly. But right now, I'm telling it to you. Guys, look at the structure of methane. It has only one carbon. I am not drawing the full structure of methane right now, but I'm just telling you. Just if you will look into the methane's formula, it is telling you that methane has one carbon as a part of its structure. As a result of that, we can never say this thing that it can have a carbon carbon single covalent bond. When there will be only one carbon, how it can make carbon carbon single covalent bond? So this is the exception here, that general formula of alkanes family is CnH2n plus 2, and the functional group is carbon carbon single covalent bond, which is implemented to all the members of the alkanes family except methane. Okay, now the second is alkene, and the general formula for alkene is CnH2n. Yes. Can we say this thing that in case of alkenes, the number of hydrogen atoms are lesser than that of alkanes? Alkanes have more number of hydrogen atoms, whereas alkenes have lesser number of hydrogen atoms, which is just telling you that from this general formula, it is clear, it is very clear, which is just telling you about number of hydrogen atoms, a small idea from the general formula. Okay, and what is the functional group? Carbon carbon double covalent bond. Okay, so remember this thing, one thing which I would like to inform you right from the scratch, right from the beginning of organic chemistry. In complete organic chemistry, you are going to have covalent bonding always, because metal is not present here. This is a combination of non-metals with each other, and in those all cases there will be covalent bonding, except. Oh my god, there are many exceptions in chemistry. I perfectly agree, I agree. Okay, then what is that exception? Where is not covalent bonding in organic chemistry? When any metal is going to react with any of the compound, for example with a carboxylic acid or with any alcohol, as a result of that, when a metal and a non-metal combination will be there, you people should have this click in your mind, oh, there will be an ionic bond now. Okay, other way around, if metal is not present, if we are not considering the reaction of any metal with them, then it is only covalent bonding present in complete organic chemistry. Okay, now what is the exception in case of alkenes? Yes, there is an exception. Oh my god, yes, there is an exception. And what is that exception? In case of alkenes family, number one member will not have one carbon atom. So we can say member number one carbon atom member, member number two carbon atom member number three carbon atom member, etc. But here in case of alkene, the first member is of two carbon atom. It is not of one carbon atom. Why? Because according to its functional group, there must be a carbon carbon double covalent bond. So how, if there will be one carbon atom only, how it can make a double covalent bond in the air? It cannot make. That's why it is requiring one more carbon atom to make a double covalent bond. Okay, now I am on the topic of alcohol. Yes, it has a general formula CnH2n plus 1 and OH. Oh, it has a separate OH. Yes, it has a separate OH. Is that compulsory to have OH in alcohols family? Yes, if there is no OH, it is never considered as an alcohol. Okay, so for an alcohol, there must be an OH in this. And what is the functional group? This carbon OH bond is the this carbon OH. Carbon and OH connectivity is responsible for all the chemical reactions of alcohols family. Remember this thing, that this is a functional group for all the alcohols family. Okay, now I am just changing the color. Okay, moving to blue. Okay, now what is the carboxylic acid general formula? It is CnH2n plus 1 COOH. They all have COOH. Where we have studied that? Yes, guys, we have discussed that COOH thingy in case of acids topic. I have discussed it with you already in detail, that there are two types of the acids. One of them are called as inorganic acids, which don't have COOH as a part of their structure, whereas the other has the other party is called as organic acids, which are also called as carboxylic acids. So they all must have COOH as a part of their structure. So there is what is the functional group? This COOH is the functional group. Guys, here I'm writing it like a bond type of a thingy, which is just telling you that how this bond will be formed. One more thing which you people should know, they think that there is another exception. OMG, we are fed up of these exceptions. I'm really very sorry for that. And what is that exception here? In case of carboxylic acids, this general formula cannot be implemented on the first member of the carboxylic acid. First member of the carboxylic acids family is methanoic acid. Yeah, weird name. I agree. Methanoic acid. In case of methanoic acid, it has one carbon, which is part of the carboxylic group. So the general formula is telling you two carbon atoms. So functional group is implemented on the first member, but general formula is not implemented on the first member. That's why this is a small exception. These are the small three exceptions which I have told you here. Right now, I am on esters. In case of esters, guys, you will not have a specific type of a general formula as a part of your syllabus. And the functional group of the esters family is basically COO. This is called as the carboxyl carbon. You may say, yahan par bhi, here there must be a carbon atom as well. So this is called as the carboxylic acid is attached further with a carbon. How it is happening, that all detail will be taught to you. But for esters, you can leave both of these points that will be discussed with you when I will teach you the topic of esters. But right now, I'm just telling you what is the general formula and functional group all of these four families, and esters is part of your syllabus. Esters will be discussed with you in detail. Right away, I am saying you that we are done with the basic concepts of organic chemistry, basic concept of hydrocarbons, general formula, functional group, characteristics of homologous series, and etc. I will teach you to the next point. I will teach you to in the next class about this next point and what will be that next point. Number of carbon atoms, number of carbon atoms associated with different names. That will be our topic for the next class, inshallah. Thank you very much. See you in the next class. All the best to all of you.